Line 22, 7b97z71. Carbon nanoparticle, nematic liquid crystal, optical nonlinear 5G Wow Seti. There's the alien radio signal. Here's another long PDF file. Keep the data together. Effect on response time and diffraction efficiency of co-uses azo dye and carbon nanoparticle and nematic liquid crystal. So the previous video was line 22, 7b97z70, pending ionization of C60 and C70 cross beams, mass detections, collisions, 5G Wow Seti. Quotes and diagrams from the PDF results are from a blog. Okay. And effect on response time and diffraction, efficiency of co-usage azo dye and carbon nanoparticles in nematic liquid crystal. The name of our scientists are from Turkey. www.sciencedirect.com is the link. And the abstract is, in this work, the formation of the photon-induced grating and nonlinear optical properties such as diffraction efficiency N, refractive index modulation triangle N, nonlinear index coefficient, okay, I'm not going to read all these symbols here, of nematic liquid crystal doped by azo dye and C60 have been investigated by diffraction grating measurements. Diffraction efficiencies of 441 nm pump and 632 nm probe beams were measured in two-wave mixing experiment. Maximum diffraction efficiency was found, 26% doped with both 1% MR and 0.5% C60, while cells without C60 had maximum diffraction efficiency of 19% under 30 NW laser illumination. Rise time was found to increase with methyl red concentration. The nonlinear index coefficient N2 was calculated to be 11 by 10 minus 3 centimeters 2 to W and highly depend on MR concentration. Keywords: liquid crystals, rise time, nonlinear index coefficient, and diffraction efficiency. So figure 1 is the chemical formulas of nematic host E7 methyl red 2,4-dimethyllimonol 5-lazobenzoic acid. And this is absorbance spectra for E7 divided by 1% MR. Again, that looks like a Higgs signal to me. Yeah, I said it again. This definitely looks like the Atlas Higgs signal found in an earlier video. Tougher part. That's all I ever talk about. Experimental setup for the two-wave mixing BS beam splitter, M-mirror, P polarization, and neutral density filter. Sorry that they're so blurry, but that's how they come up. Figure 4, dependency of normalized diffraction signals on the applied DC voltage. Inset normalized diffraction signals of MR doped. E7 normalized diffraction efficiency of the investigated samples, A and B. Okay. Figure 5 is diffraction efficiency versus percent MR. For cells with and without C60, total pump beam 30 MW, and wave mixing angle is that equation. The line is serving as a guide to the eye. Figure 6, this is nonlinear index coefficient change with MR concentration for cells with and without C60 at applied DC voltage 3.5 volts. The line is serving as a guide to the eye. Figure 7, first order diffraction efficiency versus various pump powers for E7, C60, 0.5% MR. Sample powers listed are total powers for both beams. Oh, this is even blurrier than the rest. It's not your eyes, don't worry, you don't need glasses. It's just the way it's coming up. Figure 8A. Oh, you see they quieted down just for a bit. My birdies out there, all hundreds of them. Oh. They had a little gasp of air, now they're going at it again. A time dependency of first order probe diffraction signal for various pump beam power at applied DC voltage 3.5 volts. Rise time versus total pump power for E7 C60 1% MR. Cell alignment only as a guide to the eye. This almost looks like visible light here with the red, blue, and the green. Rise times for okay, yeah, we'll just do that. My thoughts. Red, blue, green, visible light. There we go. Let's put that. And figure 8. Okay. Figure 9, rise times for various percentage MR cells with and without C60. Total pump beam power was IP equals N10 MW. Line of serving is a guide to the eye. Table 1, diffraction, efficiency, refractive index, modulation, and nonlinear refractive index, coefficient of investigated symbols. This one was nice and clear. Of course, the last one already is, eh? So this is www.sciencedirect.com where I found this data. It shows rise TAM and percentage of MR. So those are diffraction signals. Keyword PDF file, scattering dynamics of hypothermal 660 from a carbonized nickel surface at impact energies will be in the next video. Thank you for watching.